Okay, before going into this kind of a problem, we need to know what are the data has been given. In this problem, for the molecular formula C5H10O, there are two sets of spectroscopic data are given. One is IR spectroscopic data and the next one is Proton NMR spectroscopic data. IR spectroscopic data is concerned, the wave number 1720 corresponds to the presence of carbonyl stretching. And before going into the proton NMR, one need to know the presence of a double bond or a multiple bond or maybe the ring or everybody together. So to know that, it's better to solve the hydrogen deficiency index. Now how this hydrogen deficiency index is calculated? Hydrogen deficiency index is equal to 2C plus 2 minus of hydrogen divided by 2. The C represents the carbon, number of carbons. So therefore 2, and the carbon is 5 carbon plus 2. How many hydrogen? 10 divided by 2. Therefore 10 amounts to 5 into 10 plus 2 12. 12 minus of 10, 10, that is equal to 2. Therefore 2 by 2, therefore 1. Meaning there is a presence of one double bond or a ring. A caution has to be taken. This hydrogen index formula is always represents for carbon and hydrogen, right? What about the other heteroatom like oxygen? So we need to have another understanding. The nitrogen, oxygen and fluorine or any of their other congeners, example fluorine or its higher congeners like chlorine, bromine, iodine, if they present to the hydrogen index at the value 1. For the nitrogen family members, the value of -1 to be included. Luckily for oxygen, it won't contribute any of the value, therefore we simply put the value 0. In this molecule, oxygen being given, so we don't do any corrections here, we simply take it as 1. Now what this 1 signify? Maybe it has one double bond or maybe the ring. The IR data says that it has a carbonyl group. So there may be a chance of double bond and that double bond may be reflected here by the hydrogen deficiency index. Bond this in your mind. Now we'll go into the NMR data. There are 3 signals are obtained, meaning there are 3 different kinds of protons are present in the system molecular structure. Now 6 protons which shows doublet, and let's say because the shift value is at 1.0 highly upfielded, why not it could be methyl? So we have a rough case of having methyl, and it is a doublet, meaning the neighbor is having one methine group. That is why these 3 hydrogens coupled with that one hydrogen and shown to be a double. There are 2 sets of methyl is present, therefore this could be CH3. So now this is consistent with the first data. 3 protons coupled with the methine proton and therefore shown a doublet. Now going further, the other one, it shows 3 proton singlet, therefore that too at 2.10 somewhat upfielded. I may guess there is a methyl group, and to that methyl group there is a possibility of having carbon or any other heteroatom such that it doesn't have any proton, so it resulted in a singlet. That is another data one can happen. Fine. Now we'll go into the third one. There is only one proton which shows septate. Now look at this hydrogen. This is that one proton, and that one proton coupling to the 6 other proton, giving n plus 1 of splitting, where n is 6 proton, therefore 6 plus 1 7, that yielded septet, so it is already been fixed. So by this CH3 CH3 fragment is well advocated. Now there is the presence of a double bond, so why not it could be a carbonyl? I'll assume it to be a carbonyl. Now this carbonyl in turn connected to the carbon, which is having a methyl, and because this methyl proton finds no any proton nearby, I have shown singlet, as well as because they are electronegative group, it's somewhat downfielded. That is why it is shown its resonance at 2.10 delta value in ppm scale. So this is the structure of the molecule for the given data. Thank you very much.